The Moon, Earth's closest celestial neighbor, has captivated humanity's imagination for centuries. From ancient myths to the Apollo landings, it has symbolized the frontier of human exploration. Today, as we stand on the cusp of a new era in space exploration, the Moon is once again at the forefront of our ambitions. Unlike the fleeting visits of the 1960s and 1970s, modern plans aim for permanent human presence, with lunar bases paving the way for sustainable colonies and serving as a launchpad for deeper space exploration, including missions to Mars and beyond. But what would it take to live on the Moon? What challenges, opportunities, and innovations await us? This exploration delves into the future of human settlement on the Moon, drawing from visionary ideas and scientific insights to paint a picture of life on this desolate yet resource-rich world. The Moon is no longer just a destination for scientific curiosity or national pride. It represents a strategic outpost for humanity's expansion into space. Countries like the United States, China, Russia, and India, alongside private companies such as SpaceX and Blue Origin, are racing to establish a foothold on the lunar surface. Their motivations extend beyond exploration to economics and geopolitics. The Moon is rich in resources that could transform industries on Earth and fuel further space endeavors. One of the most coveted lunar resources is helium-3, a rare isotope on Earth but abundant on the Moon due to billions of years of solar radiation exposure. Helium-3 could revolutionize energy production, with just 100 kilograms capable of powering a city like Dallas, Texas, for an entire year. At an estimated value of $40,000 per 28 grams, it's a treasure trove that could drive a lunar economy. Beyond helium-3, the Moon harbors valuable metals like gold, silver, and titanium, which could be mined and potentially shipped back to Earth. These resources make the Moon a gold mine literally and figuratively for nations and corporations aiming to dominate the next space race. However, the 1967 Outer Space Treaty complicates matters. This international agreement stipulates that no nation can claim ownership of celestial bodies, including the Moon. While this promotes peaceful exploration, it could spark tensions as countries and companies vie for access to lunar resources. The race to establish a base is as much about securing influence as it is about scientific discovery, setting the stage for potential conflicts reminiscent of terrestrial resource wars. Not all parts of the Moon are equally suited for human habitation. The lunar South Pole emerges as the prime location for a base due to its unique advantages. Unlike other regions that endure month-long periods of darkness, the South Pole receives consistent sunlight, ideal for solar power generation. Additionally, it hosts vast ice fields, a critical resource for water, oxygen, and even hydrogen fuel. Water is essential not only for drinking, but also for agriculture and life support systems, making the South Pole a strategic choice for sustainable settlement. Building a lunar base, however, is no simple task. The Moon's surface is harsh, with no breathable atmosphere, extreme temperature swings, and intense solar radiation due to the lack of a protective magnetic field. To shield inhabitants, experts propose constructing bases underground or within dome-like structures made from lunar soil or regolith. Robots and 3D printers could process regolith into cement, forming layered walls that provide radiation protection equivalent to Earth's atmosphere when built 5 meters thick. These domes would house living spaces, scientific facilities, and greenhouses, connected by tubes to create a sealed, controlled environment safe from the Moon's toxic atmosphere, which is 95% carbon dioxide, and its relentless dust storms. One of the Moon's most insidious challenges is moondust. Unlike Earth's soil, lunar dust is magnetic, sharp, and highly abrasive due to the lack of weathering processes. It clings to everything: spacesuits, equipment, and even human skin, posing health risks. Previous astronauts, including those from the Apollo missions, reported allergic reactions to moondust, and its sharp particles can cause severe irritation if inhaled. For machines, moondust is equally problematic, infiltrating systems and causing overheating or mechanical failure. Solving the moondust problem is a prerequisite for long-term lunar habitation, requiring innovations in suit design, filtration systems, and dust-repellent coatings. Living on the moon demands a radical rethinking of survival. Food, water, and air, the essentials of life, are scarce or non-existent. Initially, settlers would rely on dry astronaut rations, supplemented by limited crops like carrots and tomatoes grown in lunar soil, as demonstrated by a 2014 Dutch study. However, large-scale agriculture is challenging due to the moon's toxic, chlorinated soils, which could damage the thyroid if ingested. Indoor greenhouses fertilized with manure from livestock like chickens could provide a sustainable food source. But scaling this to support a growing population requires significant infrastructure. Water presents an even greater challenge. Shipping water from Earth is impractical due to its weight, so settlers would likely recycle urine and harvest ice from the South Pole. If liquid water exists beneath the lunar surface, as some scientists speculate, it could be filtered for drinking and irrigation. The moon's low gravity, only 16% of Earth's, means water stays closer to the surface, requiring less volume for agriculture than on Earth. This could make farming more efficient, but establishing a reliable water supply remains a critical hurdle. The moon's thin atmosphere is unbreathable, necessitating sealed habitats with artificial life support systems. Oxygen could be extracted from lunar ice or regolith, but maintaining a stable supply requires advanced technology. Radiation protection is equally vital, as prolonged exposure to cosmic and solar radiation could lead to serious health issues, including cancer. Underground or shielded habitats are essential to mitigate this risk, making the construction of robust, radiation-resistant structures a top priority. Life on the moon would be far from glamorous. Early settlers would spend most of their time mining resources, maintaining equipment, and ensuring survival. The low gravity, while allowing for fun activities like bouncing around, poses long-term health risks, including muscle and bone loss. To stay healthy, settlers would need rigorous exercise regimens and high-protein diets, potentially requiring the equivalent of 110 cooked chicken breasts and 660 carrots daily to feed a small colony of 110 people. These demands highlight the need for self-sufficiency, as supply shipments from Earth would be infrequent, arriving only every 2 years when Earth and the Moon align optimally. The lunar economy could take a unique form. Traditional currency like cash is too heavy for space travel, and credit cards would be impractical due to the 14-minute communication delay between Earth and the Moon. Cryptocurrency like Marscoin, adapted for lunar use, could facilitate trade, or settlers might rely on bartering goods and services. This nascent economy would support the development of a lunar government to manage resources like water and oversee infrastructure, laying the foundation for a new society. The moon is more than a destination. It's a proving ground for humanity's broader ambitions in space. Establishing a lunar base is seen as a baby step toward colonizing Mars and exploring exoplanets like Proxima b or Kepler-22b. The technologies developed for lunar survival, radiation shielding, resource extraction, and sustainable habitats will be critical for Mars, where settlers face similar challenges like toxic dust, low gravity, and a thin atmosphere. The moon's proximity to Earth, just a few days' travel compared to Mars' 8-month journey, makes it an ideal testing ground for these systems. Moreover, the moon could serve as a launchpad for deep space missions. Its low gravity reduces the fuel needed for spacecraft launches, making it an efficient staging point for missions to Mars or beyond. Helium-3, extracted from the lunar surface, could power advanced propulsion systems, enabling faster and more efficient space travel. By mastering lunar colonization, humanity can develop the expertise and infrastructure needed to reach farther into the cosmos. The broader vision, space megastructures and beyond, while the moon offers a practical starting point, Some visionaries propose even grander solutions for human expansion, such as constructing megastructures like a ring world or an Alderson disk. A ring world, encircling the Sun with a radius of 150 million kilometers, could house trillions of people on a surface area equivalent to 1 billion Earths. Spinning at 2 million kilometers per hour to generate artificial gravity, it would require materials from across the solar system, possibly sourced from the Kuiper Belt or dismantled planets and asteroids. An Alderson disk with the mass of 3,000 suns would stretch beyond Mars' orbit, offering vast habitable zones, but facing risks like asteroid impacts or gravitational collapse. These megastructures, while theoretically possible, highlight the immense engineering challenges of space colonization. The Moon, by contrast, is a more achievable goal with current technology. Its resources and proximity make it a practical first step, while its challenges push the boundaries of innovation. Lessons learned on the Moon could inform the construction of these megastructures, ensuring humanity's survival even if Earth becomes uninhabitable due to climate change, asteroid impacts, or solar flares. Challenges and ethical considerations. Settling the Moon raises profound ethical questions. The potential for geopolitical conflict over lunar resources underscores the need for international cooperation. The Outer Space Treaty aims to prevent militarization and ownership disputes, but enforcing it in a resource-scarce environment could prove difficult. Additionally, the environmental impact of mining the Moon must be considered. While the Moon lacks ecosystems, large-scale resource extraction could alter its surface and affect future scientific studies. The human cost of lunar settlement is another concern. Early settlers would face extreme isolation, confined to underground habitats with limited recreation. The psychological toll of living in such conditions, coupled with health risks from low gravity and radiation, requires careful planning. Selecting and training colonists will be critical, as will developing technologies to maintain their physical and mental well-being. The Moon represents humanity's next great frontier. Within the next decade, we are likely to see humans return to its surface, this time to stay. Whether driven by the promise of helium-3, the allure of a new society, or the necessity of a backup planet, lunar settlement is a pivotal step in our journey to the stars. The challenges moondust, radiation, resource scarcity are formidable, but so is human ingenuity. By building sustainable bases, harnessing lunar resources, and developing new technologies, we can transform the Moon from a barren rock into a thriving outpost. This endeavor is not just about survival. It's about redefining what it means to be human. A lunar colony could foster a society free from Earth's constraints, with new economies, governance models, and ways of life. It could also unite humanity in a shared goal, transcending national boundaries to create a legacy for future generations. As we look to the Moon, we see not just a destination, but a stepping stone to Mars, exoplanets, and perhaps even megastructures that could house billions. The future of human exploration begins here, on the dusty, desolate, yet infinitely promising surface of the Moon.